previous I discussed the fourth question. The same way I am going to represent the question number 5. Here also it is 3 equations are there. You are going to get 3 by 3 matrix. The same logic. Coefficient of x. First matrix, what you have? Coefficient of x is 3. Coefficient of x is 3. In the second equation, you didn't have a coefficient of x. So, you consider as 0. In the third equation, 3. Right? Next, coefficient of y. First equation, coefficient of y is -1. In the second equation, 2. In the third equation, -5. While writing the things, you have to be very careful. Here x is not there. In the third equation, z is not there. First equation, coefficient of s is -2. Coefficient of z is -2. Coefficient of z is -1 in the second equation. In the third equation, you have no. So, you consider as 0. The next, what I said, the collection of the variable. What are the variables are used in this equation x, y, z? Always you should write it in the column, which is equal to the constant. What are the constant exists? That is also should be represented in the column. Right? This one you consider as A. The x, y, z you consider as capital X. The constant you consider as capital B. The same thing what I said in the fourth sum, the same thing, right? Now, immediately what you want to find? Determinant A. Determinant A equal to determinant 3 minus 1 minus 2 0 2 minus 1 3 minus 5 0, which is equal to 3 into, straight away I am going to write, right? If you are selecting this, that particular row and column should be deleted. You are getting the element as 2 minus 1, 2 minus 1, minus 5, 0. So, 2 into 0, 0, minus 1 into 5, 5. Next element I told you positive, negative. Here you are having a negative, so it become positive. Plus 1 into the same column, the second column and the first row should be deleted. You have 0, minus 1, 3, 0. 0 into 0, 0. Minus 3 into minus 1, minus 3. Minus into minus what? Plus 3. Plus, here you have minus 2. But our based on the rule we have positive. Positive into negative, negative. Positive into negative, negative. Positive into negative, negative. So, you get it as minus 2 into bracket. The particular row and column should be deleted. The rest of the entries are 0, 2, 3, minus 5. 0 into minus 5, 0. 2 into 3, minus 6, which is equal to 3 into minus 5, minus 15, plus 3, minus 2 into minus 6, plus 12. What you arrive? Minus 15 plus 15 equal to 0. See, if determinant A is not equal to 0 only, you can conclude the system is consistent, it has unique solution. When you arrive determinant A equal to 0, immediately you want to evaluate adjoint of A into B. adjoint of A into B. For that you want to find cofactor of A. What is our A here? A is 3 minus 1 minus 2. A is evaluate adjoint of A into B. For that you want to find cofactor. The cofactor I am going to write it in the right side. Center element, then below what it is? Minus 5, above minus 1, then again the same entry you want to write it as 2. Next you move towards right. Minus 1, 0, minus 2, minus 1. Minus 1. Next move towards left. 0, 3, 3, 0. 0, 3, 3, 0. The same element you are going to write it at the end. Minus 5, minus 1, 2. Now we want to find cofactor. Using the cofactor only we want to find adjoint, right? Now cofactor of A. Cofactor of A equal to 0 minus 5. So I am going to write straight away minus 5, right? 2 into 0, 0, minus 5 into minus 1 plus 5. You will get it as minus 0 minus 5 is minus 5. Next minus 1 into 3, minus 3, minus 0. So minus 3. Next 0 into minus 5, 0, minus 3 2s are 6. You write it as minus 6. You write it as minus 6. Next minus 5 into minus 2, minus 10. Minus 1 into 0, 0. 3 into 0, 0, minus of minus 2 into 3. Minus into minus plus, so you will get it as plus 6. Next minus 3, minus of minus 15. Minus 3, minus of minus 15, that is plus 15. 3, minus 3 plus 15. Minus 3 plus 15. So what you will get? 12. Next minus 1, minus of minus 4. Sorry, minus 1 into minus 1 plus 1, minus of minus 4, you will get it as positive. So 1 plus 4, 5. Minus 2 into 0, 0, minus of minus 1 into 3 plus 3. Next 3 2s are 6. Here you are getting 0. So 6. Again I repeat, you listen. 2 into 0, 0, minus 1 into minus 5 plus 5, 0 minus 5, that is why I wrote minus 5, minus 1 into 3, 0 into 0, 0, so directly I wrote it as minus 3. Here 0 into minus 5, 0, 3 2s are 6, 0 minus 6, I got it as minus 6. Here you see minus 5 into minus 2 plus 10. Minus 5 into minus 2 plus 10 minus 0. Here also the same. 3 into 0, 0, minus of minus 6. So plus 6. Minus 3, minus of minus 15. Minus 3 plus 15. So I wrote it as plus 12. Minus 1 into minus 1 plus 1. Minus of minus 4, 5. Here it is 0, minus of minus 3, positive as 3. 3 2s are 6, minus 0, so I wrote 6. Cofactor we found. What is our adjoint of A? Adjoint of A equal to, I told you the transpose of cofactor. How I am going to write, you see, minus 5, 3, minus 6, 10, 6, 10, 6, 12, 5, 3, 6. We got it as adjoint of A is minus 5, 10, 5, 3, 6, 3, minus 6, 12, 6. Okay. The row you converted into column. Minus 5, minus 3. Sorry. Minus 5, minus 3. Right? Minus 5, minus 3. While writing the things, you have to be careful. Don't commit mistake. Right? Now, adjoint of A into B we want to move. Adjoint of A into B equal to minus 5, 10, 5, minus 3, 6, 3, minus 6, 12, 6. What is our B? B is 2, minus 1, 3. 2, minus 1, 3. Right? First row, first column, which is equal to minus 10, minus 10, plus 15. Right? 2 minus 1, 3. Minus 5 into 2, minus 10. Next, second row, this column, the column, right? Minus 6, minus 6, plus 9. Here, minus 12, minus 12, plus 18. So, what we are going to get the answer, you see, minus 10, minus 10, minus 20, 20 plus 15, minus 20 plus 15, do the subtraction and put the greater number symbol, that is minus 5, minus 6, minus 6, minus 12, plus 9, do the subtraction and put the greater number symbol, that is minus 3, minus 12, minus 12, minus 24, plus 18, minus 24 plus 18, what you arrive? Minus 6, which is not equal to 0, right? Here you are arriving determinant A equal to 0. Once if you arrive determinant A equal to 0, we want to find adjoint of A. Then you have to multiply adjoint of A with B. You have to check whether it is equal to 0 or not. If it is not equal to 0, the conclusion is adjoint of A into B not equal to 0. Therefore, the system is inconsistent. Inconsistent means what? It has no solution. It has no solution. See, again I repeat, adjoint of A you should check minus 10 plus 15, minus 6 plus 9, minus 6 into 2, corresponding entries you have to multiply, right? Minus 12 plus 18. So, minus, sorry, what I want to write here, minus 6, right? Minus 6 into 2, minus 12 plus 18, minus 20 plus 15, minus 5, minus 12 plus 9 minus 3, minus 24 plus 18 minus 6, definitely it is not equal to 0. Once if you arrive adjoint of A into B is not equal to 0, the conclusion is that the system is inconsistent, it has no solution. That is the conclusion, I wrote it at the end. The previous one we discussed whether the system is consistent or inconsistent. Now I am going to solve using the matrix inversion method, or you can say matrix method. See, the same what I discussed in the previous, you recall it, right? Two equations are there. Collection of x in the first column, collection of y in the second column, that is the base, right? Coefficient of x 5, 7 over. Next you will pass on to coefficient of y. What is coefficient of y? 2, 3. What are the variables they used here? X, y. It is a two equation, so they are using two variables. So that is x, y equal to the constant. The constant and the x, y you are making as a column matrix, whether it is 2 by 2 or 3 by 3, the same thing only you can use. Now I told you the collection of coefficient of x and y should be represented as capital A. The variable you should represent it as capital X. The constant you represented as capital B. I said matrix inversion method, right? You have some doubt what it is. I am going to explain that. Ax equal to B. Ax equal to B. When you can apply matrix inversion method, if the pair of linear equation or if the determinant is not equal to 0. If the determinant A not equal to 0 only, you can apply matrix inversion method, right? Now x is equal to the A, when you shift to this side, it will come under 1 by A. The 1 by A, I am going to write it as A inverse. 1 by x means x, when you raise to the numerator, x to the power minus 1, the same basic concept I used here, into B. When you shift A, you should place it in the first position, that is the rule. X is equal to A inverse B. X is equal to A inverse B. What is the formula we had? A inverse equal to 1 by determinant A into adj A. That's why I said the topic is application of determinant and matrices, that is combination of determinant and matrices. Determinant and matrices, right? Now first you want to find determinant A. Determinant A, you are going to place A in the form of determinant 5, 2, 7, 3, which is equal to 5 3s are 15 minus 14 equal to 1, not equal to 0. If the determinant A not equal to 0, you can say the system is consistent, it has unique solution. And one more thing you can say, it A inverse exists. A inverse exists. Two things we can conclude using the determinant A. Two things we can conclude using the determinant A. If determinant A not equal to 0, first one is the system is consistent, it has unique solution. The second one you can say inverse exists, right? Now what are the things we need? Determinant A we got it. Adjoint of A. Adjoint of A equal to, I taught you if it is 2 by 2, you can find easily the adjoint. How to find adjoint? Change the main diagonal entries. Change the main diagonal entries. Change the symbol of sub-diagonal entries. Change the main diagonal entry, that is 3, 5. Change the symbol of subdiagonal minus 2 minus 7, right? In A inverse we had 1 by determinant A into Aj A. For that I found a determinant A and Aj A. I said using determinant A we can say two things. One is the system is consistent, it has unique solution. Another one is inverse exists. Now I am going to do X is equal to A inverse B. First we have to write A inverse equal to 1 by determinant A is 1. What is your Aj? Aj is 3 minus 2 minus 7, 5. 1 by 1. If you are multiplying by 1, whatever it is, you will get it as the same. So, what you will get? 3 minus 2 minus 7, 5. A inverse we got it. We know what is B. Using that we are going to find the value of X and Y. Now X should be replaced in terms of XY equal to, because A inverse and B we are going to represent in the matrix. Same way X and Y can be represented in the matrix as XY equal to, what is your A inverse? A inverse is 3 minus 2 minus 7, 5 into, what is your constant you had? 4, 5. Right? X is equal to A inverse B. A inverse and B you are having a matrix. So X also I represented in the matrix. The X what we consider? The matrix, column matrix XY, that's it, right? Which is equal to first row, first column. 3 4s are 12, 2 into 5, 10, minus 10. Next, second row, first column, minus 28 plus 25, which is equal to 2 minus 3. Now what is the value of X? X is equal to 2, Y is equal to minus 3. What is our answer at the end? X is equal to 2 and Y equal to 3. If you want, you write it in the matrix format, or you equate X is equal to 2, Y is equal to minus 3. Because the system is consistent, you are arriving the solution as X is equal to 2 and Y is equal to minus 3. The same way, question number 7, how I proceeded, the same way I am going to do question number 8. See here, coefficient of X should be placed in the first column. Coefficient of Y should be placed in the second column. Then you get it as 2 by 2 matrix. Then the variable used as X and Y, you write it in a column. The constant minus 2 and 3. Right? Now, this as A, capital X equal to B. Matrix inversion method I said, right? X is equal to, when you shift A to this side, you have to place it in the first position. A inverse into B. What is A inverse? A inverse equal to 1 by determinant A into Aj A. 1 by determinant A into Aj A. Now we want to find determinant A. Determinant A equal to determinant 2 minus 1, 3, 4, which is equal to 2 4s are 8 minus 3 into minus 1 minus 3. 8 plus 3 equal to 11. So it is not equal to 0. Determinant A not equal to 0 means I told you A inverse exists and the system is consistent, it has unique solution. You just recall it, right? Now, adjoint of A. Adjoint of A equal to 2 by 2 matrix, it is easy for you. Change the main diagonal entry. That is shifting the main diagonal entry. Change the symbol of subdiagonal. If it is negative, you will get it as negative. If it is positive, if it is negative, we make it as positive. If it is positive, make it as negative. So what you will get here? 1 minus 3. What are the things we want to find? A inverse, determinant A and XII. That I got it. Now I am going to write A inverse equal to, A inverse equal to 1 by determinant A. That is 1 by determinant A is what? 11. Adj 4, 1 minus 3, 2. A inverse over. But what is our format? X is equal to, our format is X is equal to A inverse B. Here you are having A inverse as matrix, B is also matrix. So the X is also, you have a matrix. You are going to replace everything in terms of matrix. Now X, Y equal to 1 by 11 into 4, 1 minus 3, 2 into B. B is what? Minus 2, 3. See, the 1 by 11 you keep as such. First you should do the multiplication, this part alone. Finally the answer should be divided by 11. That is easy for you, right? Don't keep the number in the fraction format. 1 by 11, 4 into minus 2, minus 8, plus 1 into 3, 3. Minus 3 into minus 2, plus 6. Minus 3 into minus 2, plus 6. Then what you will get? Plus 6. Right? Which is equal to 1 by 11 into minus 5, 12. Which is equal to, you write like this, X, Y equal to, using the 11 you should divide, minus 5 by 11, 12 by 11. Right? Again I repeat, 2, the coefficient of X you have to write it in the first column, coefficient of Y you write it in the second column, the variable you place it in the column matrix, the constant also the same. Then you write X equal to B, X is equal to A inverse B. A inverse equal to 1 by determinant A into XII. Determinant A equal to 2 minus 1, 3, 4. Main diagonal minus subdiagonal. You arrived as number as 11, which is not equal to 0. Using determinant A, you can say two things. One is the system is consistent, it has unique solution. Another one is inverse exists, right? Inverse exists only, you can find the solution. Adjoint of A equal to, adjoint of A means what you want to do? Change the main diagonal entry, change the symbol of subdiagonal. If it is negative, positive, positive means negative. Then A inverse equal to 1 by determinant A into XII. Everything now we are going to replace in terms of matrix. The X can be replaced by XY. A inverse you have the result. B you have minus 2, 3. Then you keep the fraction outside as such, you don't disturb. This alone you have to multiply. 4 into minus 2 minus 8 plus 1 into 3 3 minus 3 into minus 2 plus 6 plus 3 2s are 6. So what you will get? 1 by 11 minus 8 plus 3 minus 5, 6 plus 6 12. So use the 11 and divide. Minus 5 by 11, 12 by 11. Therefore, what is your x now? X is equal to minus 5 by 11. Y is equal to 12 by 7. Sorry, 12 by 11. Suppose if they are asking, you can say the system is consistent and it has unique solution. It has unique solution, right? If you arrive x and y as a value, you can say it is consistent and it has unique solution.